Okay, so there's another way to measure the spring constant, and that's by exploiting the harmonic properties of the spring. So this means we can use this equation, which tells us that t, the period of oscillation, is equal to 2 pi times the square root of m over k, where m is the mass on the end of the spring, and k is the spring constant. So I want to rewrite this equation to get rid of the square root, which means I'm going to square both sides. That gives us t squared equals 4 pi squared divided by k times m. And I'm going to write it this way because we're going to use this form of the equation later on.
Okay, so I'm going to make a measurement to get the period for a 300 gram mass on the end of our spring. So if I put this into harmonic motion, what I'm going to do is I'm going to measure the time of 10 oscillations, divide that number by 10, and that will be the period of one oscillation. So let's get this going. I'm going to start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 8.69 seconds is the time for 10 oscillations. Divide that by 10. 0.869 seconds will be the period of one oscillation. And I want to square that number. That's 0.755. Okay, so off screen, I'm going to make 2 more measurements. And so I'm going to do 0.4 and 0.5 kg. So on the data sheets, we'll give you the period and t squared for those experiments. And what we want you to do is plot m and t squared. So t squared versus m, you're going to have 3 data points. And like in part 1, you're going to fit this with a line. And now your slope is going to be this value right here. Okay, so slope of this line that we just graphed will be 4 pi squared divided by k. Okay, so you're going to use this to give us k, and now we have k measured in a different way.